Hello everyone. Today we are going to discuss about one of the most important straight lines in mathematics. Do you know what this line is? Yes, it is the line which you can see right on your screens. This is called the number line. But why is the number line so important? I mean, we have already learnt about it in our previous classes, so why are we going to discuss it again? We all know that mathematics is all about numbers. So, before delving deep into the subject, we must learn about the number systems itself, and we will do so with the help of a number line. We are going to discuss number line again because although we have learned it in our previous classes, we still may not know all the numbers which may exist on the number line. So, let's get to it. Suppose you go to the market to buy a pen. So what you will do is, you will go to the shopkeeper and ask for a pen. The shopkeeper counts one pen and gives it to you. Suppose the next customer wants to buy two pens. So the shopkeeper again does the same thing, but this time he counts two pens and gives it to the customer. In a similar manner, other customers may come in and may ask for 3 pens, 4 pens, 5 pens and so on. So these numbers, which can help the shopkeeper count the number of pens naturally, or let's say any object for that matter, they are called natural numbers. The set of natural numbers is written as 1, 2, 3, 4, 5 and so on, and it is denoted by the symbol n. Now suppose the next day you realize that there is a leak in the pen. So what you will do is, you will go to the shopkeeper, return him the pen and take your money back. So now, how many pens do you have left? You have no pens left. But how will you represent it mathematically? No is not a number, not any kind of a number. And you can't say that I have got 1 pens, 2 pens, 3 pens and so on, because you actually have no pen. So then comes the number 0. 0 basically defines no or nothing, or let's say 0 defines an empty set. So this 0, when added to the set of natural numbers, gave us an entirely new set, which was called the set of whole numbers. Now if I want to compare the set of natural numbers and the set of whole numbers, how will I do it? I will observe both the sets carefully and I will say that every natural number is a whole number, but every whole number is not a natural number. This is because every natural number 1, 2, 3, 4 and so on, they are in the set of whole numbers, but 0, which is only a whole number, is not a natural number. Now let's get to the next situation. Suppose the shopkeeper had bought the pen for Rs 4 and sold it to you for Rs 6. So what will be his profit or gain from this transaction? Yes, he had sold it for Rs 2 more, so he will have a profit of Rs 2, or we can say plus 2. Now suppose the shopkeeper had bought it for Rs 4 and sold it to you for Rs 4. So now what will be his profit? He will have no profit or no loss. But now, if the shopkeeper had bought it for Rs 4 and he sold it to you for Rs 2, then is he making any profit? No, he is not making any profit. The shopkeeper here is making a loss of Rs 2. So profit and loss are opposite of each other. So if loss is plus 2, we have to say that the profit is minus 2. So we can see how negative numbers also exist. So when we put these negative numbers minus 1, minus 2, minus 3 and so on to the set of whole numbers, they gave us an entirely new set, which is called the set of integers. The set of integers is represented by the symbol Z. So now if we compare the set of whole numbers and integers, what we can see is that all whole numbers are integers, but all integers are not whole numbers. This is because the whole numbers starting from 0, 1, 2, 3, 4 and so on, they are also integers, but the negative numbers which are integers, they are not whole numbers. So till now what we have saw is that all natural numbers are whole numbers, but all whole numbers are not natural numbers, which gives us the following combination of sets. And we have also seen that all whole numbers are integers, but all integers are not whole numbers, which further gives us this combination of sets. So now this combination of sets, which you can see on your screens, this is a subset of rational numbers. Subset means that it is only a part of rational numbers. So now the question arises that what are rational numbers? So rational numbers are basically those numbers which can be represented in the form of a ratio p divided by q, where p and q both are integers and q is not equal to 0. So your question would be, neither the natural numbers, whole numbers or integers are represented as a ratio. So why are they called rational numbers? Let us see. So we will take three numbers which are exclusive to either one of the sets, integers, whole numbers and natural numbers. Let's take the numbers -2, 0 and 1. We will check whether we can represent these numbers in a form of a ratio. So -2 can be represented as -2 divided by 1 or -4 divided by 2 or any such number. We can represent it in any form of a ratio. So -2 is a rational number because both the numerator and denominator are integers and the denominator is non-zero. Now let's check for the number 0. 0 can be represented as 0 divided by 1, 0 divided by 2, 0 divided by 3 and so on. So in this case, the numerator and the denominator both are integers, and although the numerator is 0, the denominator is not 0, which means 0 is also a rational number. Now if we check for the number 1, 1 can be represented as 1 divided by 1, 2 divided by 2 and so on. So even here, we can see that the numerator and denominator both are integers and the denominator is non-zero, which means 1 is also a rational number. So what we saw till now is that this is a subset of rational numbers, which means it is only a part of rational numbers, which means that there may be other numbers which are also rational numbers. Let us find those numbers. If we see the number line, we can see integers. But have you ever wondered what lies in between these integers? For example, let us take the numbers 1 and 2. So can we find any other number which lies between 1 and 2? Yes, we can find these numbers. And the simplest way to do is that we will find the average of the two numbers. If we find the average of the two numbers, it will give us a number which is in between the numbers. So the average of 1 and 2 gives us 1.5. 1.5 lies exactly between 1 and 2. So now if we want to find more numbers in this way, what we can do is that we can take the average of 1 and 1.5 and also the average of 1.5 and 2. So the average of 1 and 1.5 gives us 1.25 and the average of 1.5 and 2 gives us 1.75. So now let us see another method to find these numbers. Suppose someone asks you to find 9 rational numbers between 1 and 2. So what you will do is that you will represent 1 and 2 in the form of a ratio. What will be the ratio? The denominator of this ratio must be 1 more than the number of rational numbers you have been asked to find. For example, you have been asked to find 9 rational numbers. So the denominator of the ratio must be 10, and 1 can be represented as 10 divided by 10 and 2 can be represented as 20 divided by 10. We have taken these ratios because we wanted to keep the denominator as 10. So now if we keep on increasing the numerator by 1, we will get 11 by 10, 12 by 10, 13 by 10 and so on up to 20 by 10. So in this way we have got 9 rational numbers between 1 and 2. In this way we can find n number of rational numbers between any two numbers. We have to just put the denominator as 1 more than the number of terms you need to find. In this manner we can find lakhs and crores of terms between two rational numbers. So from this arises another important statement which says that between any two rational numbers there lie infinite rational numbers. So even if we take the numbers 1 and 2, there lie infinite rational numbers between 1 and 2. So we have learned that what are natural numbers, what are whole numbers and what are integers. We also learned that these all are a subset of rational numbers. And we also checked the fact that between any two rational numbers, there lie infinite rational numbers. So now my question would be, is this all? Have we seen all the numbers which may exist on the number line? No, there are more numbers which lie on the number line. You might think that this guy has gone crazy. He has shown us infinite rational numbers which can lie on the number line and he says there are more numbers. So do you want to know what all these numbers are and how this number line accommodates all these numbers? We will learn this in the next video. Thank you.